So today's session is all about understanding the version control mechanism and all those things. Before we start understanding what is version control, so anyone in the room can explain what is version control? What do you mean by version control? What is the importance of it? Can anyone tell me in the room? Vinay, Kiran, Abdullah, Manish, anybody? Hmm? Anybody in the room? What do you mean by version control? What do you exactly understand by version control? I hope I'm audible, right, everybody?
Yeah,
Yes.
you're audible.
Yeah, so no one was answering, that's why I had a doubt.
Like this track the changes and everything.
Mhm. Track the changes. And what else?
Yeah, track the changes. Maybe we can get roll back and
Mm-hmm. Roll back. Okay.
we can track the changes also, right? So previous
Mm-hmm.
question, latest, what are the changes happened?
Okay.
Yeah. Mm.
So version control is a sophisticated framework that meticulously records changes to files over time, enabling teams to retrieve, compare, and restore previous versions whenever needed. As everyone said, yes, everyone is right here, which records changes to the files made over time, enabling teams to retrieve, compare, and restore previous versions whenever needed. While it is essential for software collaboration, tracking the edits, and preventing conflicts in development projects, version control has evolved far beyond code. Now empowering designers, writers, and diverse teams managing any evolving digital asset. Previously, version control was something that was related to only for software collaboration or any coding related files. Now it has evolved beyond the software industry, where a lot of designers, a lot of video editors, a lot of content writers are using this Git to full effectiveness, managing any evolving digital assets. So version control is not something only for software industry. It is for any industry involving any digital asset. Let it be a Word document, Excel file, or whatever it is. At its core, version control transforms chaos into order, making collaborative work seamless and reversible. Okay. How many of you have heard for the first time that even the designers, even the movie industries, or even the content writing team, or even any digital marketing team uses Git for their tracking? How many of you have ever known about this? Yes. How many of you know about this? Like guys, Gaurav, Kiran, Manish, Vinay, Radhika, Amrita. How many of you have known about this? Like version control was beyond software industry. So, what was the pre-VCS era? A digital Wild West. Before modern version control came into picture, software development was a challenging and often chaotic endeavor. What is happening is like manual file management. Developers copied file and using cryptic naming conventions like some final underscore v2 underscore real underscore final dot c. So we used to maintain the backup of each and every file. So relying on tape backups now whatever hard drive you have, it was built on electromagnetics. So back in those days, it was built on tape. Tape-based backups was common, but cumbersome and prone to data loss. Constant risk. Work was often lost. They might be overwritten, and there was no audit trail or easy rollback. This was a pre-VCS era where we used to manually manage the files. If you have met any designers of Photoshop or something, they'll say underscore final version 2 underscore final version 3 underscore final version 4 underscore final version approved underscore v1. We used to maintain all this kind of files, especially designers used to maintain all this kind of files. Even when we wanted to submit our college report also, we used to maintain underscore 1 underscore 2 underscore 3 for easy rollbacking what we believe, underscore professor approved underscore professor not approved underscore approved version 2, like that. So this was a pre-VCS era. That was a digital Wild West. Since this was very challenging and chaotic to manage or maintain, the first First era of version control management started with local version control systems. What is this local version control systems? It is, we will say, how developers first started keeping track of their work. We will understand the things. So this local version control system means what? It is something like that we maintain it in our local system only. We are not exposing it to the outside of our system. So in 1962, the first version control mechanism is known as IEB update. Think of this like a early save file mechanism for mainframe programs. It started when the version control system concept started with mainframe programs, like a logbook for a recipe. It kept a record of each and every change so that teams could update code more carefully instead of starting from scratch every time. So the concept of this IEP update is something like came from the concept of a logbook for a recipe. Like it keep tracks of every change made in that file so that teams could update the code more carefully instead of starting from scratch every time. Now, come to the year 1972, SCCS. SCCS was one of the tools that was inspired by the concept of personal diary for code. Every change was written down with who made it, when, but only one person could write at a time. That was a problem. A bit like passing around a notebook in the class. IEB update inspired from the concept of a logbook. SCCS was inspired by a concept of a personal diary, where it used to say, where here it used to keep a track of the changes. Here it is say it will keep a track of the changes along with who made it, at what time they have made it, but only one person could write at a time. That means only one notebook can be used in a class of a sort. RCS. RCS stands for Revision Control System. So SCCS stands for source code. I mean SCCS full form VCS. Source code control system. Source code control system was something that was invented in Bell Labs. RCS is like it looks like word work like a word. I mean RCS stands for Revision Control System. It worked a lot like words track changes feature. That means instead of saving the whole file again and again, it only stored what changed, making things easier to manage and save space. Prior to RCS, SCS, CCS, and IEB update, what they used to do, they keep a track of all the changes. Like they keep a track of all the changes, but they will keep on saving the whole file again and again. That was the problem. What used to happen? It used to consume more space and more time, more space and more memory. So what happened? Instead of saving the whole file again and again, it only stored what has changed, making the changes easier to manage and save space. So this was one of the revolutionary concept RCS, that is revision control system. Clear? Is this clear, everybody? What is mean? What are the local version control systems that they have kept a track of it? Of course, this is something that is kept within the system. It is not like spread across the internet, because by this time, internet has something that didn't even evolve also that efficiently. Clear, everyone? Manish and all? Yes. Yes. The rise of centralized version control systems. How teams first learn to share and collaborate on code. In the year 1986, it was a major breakthrough. CVS was like a shared Google Doc before Google Docs even exist. It's like a shared Google Doc. Everyone connected to one master copy on a central server, and multiple people could work at the same time without constantly sending files back and forth. This was a major breakthrough because here in RCS or pre centralized version control systems era, we used to share the files manually still to the peers. Now we have one master copy stored in a common server, and multiple people could work at the same time without constantly sending files back and forth. This is the major breakthrough. Then, in the year 1995, Perforce Interface. It was like a heavy duty filing cabinet for giant companies. So Perforce Interface Enterprise is where it was made to store huge amounts of code files safely without slowing down when teams and projects got really big. So CVS breakthrough was started in 1986. 1995 just didn't do something magical, but they have ensured that to have when the projects grow really big, the file should be maintained efficiently in the centralized server, no loss of data, and everything should be safe and secure. That was the only thing Perforce Enterprise was weighing upon. Then come in the year 2000, that is Subversion. Subversion was like a better organized shared filing system. It made saving work more reliable. Either everything saved correctly or nothing did. No half-finished messes left behind. That was a beautiful thing of Subversion. SVN. I hope a lot of people here have used SVN in the initial days of your career, maybe. Might not be for the new people, but for the old people who are there. Like Kiran Kumar during your starting of your career days, or someone with 10 plus years of experience, I might have experienced Subversion, right? As a repository. So that's the thing.
Yes, yes.
So Subversion was like a better organized file sharing system. It made work more reliable. That means what? It either saves the complete file or nothing will be saved. That was the whole concept behind SVM. Whereas in other version control system, that was not the case. Sometimes the data file may be corrupted. Sometimes half the times file might not be saved correctly. Half the times half the content will be saved properly. This CVS and Perforce Enterprise was something I personally didn't work it, but I got to know from some of my relatives and all where they were using all the CVS and Perforce Enterprise back in their olden days. That is why I was able to put it here. Why centralized systems matter? One main server made it easier to keep things organized for you and in sync. But it also meant one big problem. That means what? If that server went down due to some natural disaster and some calamity, nobody could work. Imagine one shared filing cabinet catching fire. Everyone loses access instantly. That was the problem with the centralized version control system. That means what? The advantage is that one single server kept things organized and in sync. But it also meant one problem. If that server went down, nobody could work. I hope everyone in the room is clear what is centralized version control system. Cool. So what was the turning point? The year 2005 marked a pivotal moment in the version control history, born from a licensing dispute that challenged the core of open source development. That led to the birth of Git. BitKeeper's dominance. Before 2005, the Linux kernel community relied heavily on BitKeeper, a proprietary VCS for its large-scale distributed development needs. So the year 2003 to 2005 was the era where Linux was still in the nascent stages, and Linus Torvalds, the founder of Linux operating system, relied heavily on BitKeeper, a proprietary VCS for its large-scale distributed development needs. In 2005, a licensing dispute led to BitKeeper revoking its free usage for Linux kernel developers. So in the year 2005, there was some licensing case or some court case happening between Linux and BitKeeper, which led to revoking its free usage of for Linux kernel developers, leaving the community without a suitable tool. Then Linus Torvalds, the Linux creator, famously developed this Git concept, Git in just 10 days. Imagine, guys, he has developed the Git in 10 days, prioritizing speed, distributed workflow, and strong data integrity. This was the whole story behind the birth of Git. It was not brought into the system because it was needed, because he was so frustrated with the BitKeeper's dispute court case. He has just developed Git in 10 days, which led to prioritizing speed, distributed workflow, and strong data integrity. The first official Git commit was happened on April 7, 2005. It wasn't just a code. It was a foundation for a revolution in collaborative software development. The first Git commit happened on April 7, 2005, guys. From there on till 21 years, we have the Git still rules, guys. No matter how much we are in the AI era or something, there must be someone to keep a track of your changes. Git is still something that is still very, very much important. Clear? This is a story of Git. What happened in the year 2005? So actually from the year 2003, Linus Torvalds was building an open source operating system in order to challenge Windows. That was the whole story behind it. Then later, a dispute with BitKeeper led to development of Git in 10 days. And the first official commit happened on April 7, 2005. Clear, everybody? Any doubts? Any doubts, guys, so far? Right. Now, the rise of distributed contemporaries, like in the year 2005 and 2010, a lot of with Git rapidly gained a lot of traction. It wasn't the only distribution version control system to emerge in the mid 2000s. Several companies like Mercurial, Bazaar, and Dax were the other companies which led to distributed version control system mechanisms. Got it? So Mercurial was some this is some distributed version control system. This was created by Matt Meckel, which was a direct response to BitKeeper controversy. It prioritized user friendliness, a simpler command set, and a stronger performance with large code bases. That was the intention what Mercurial has launched. The other players like Bazaar, developed by Canonical. I mean, Canonical is also part of Ubuntu, which focused on flexibility and ease of use for small teams. And Dark stood out for his mathematical patch theory, offering advanced capabilities for managing complex changes. But despite Mercurial, Bazaar, and Darks, not many people would have heard of it because Git is the whole and soul player when it comes to distributed version control mechanisms. Mercurial found strong adoptions in major projects and companies. For more, so Mercurial was one of the distributed version control system that was used in Firefox development and used extensively by Facebook for its vast infrastructure. Till date, Firefox and Facebook are the prominent companies that Mercurial is still being used. Despite Mercurial technical prowess and adoption by large players, Git's aggressive feature development, flexible architecture, and early embrace by GitHub ultimately secured its overwhelming market share. That's absolutely true. Because Mercurial is something only big companies were using it, which we even don't know it. But Git is something that is used by even a startup company, even by a mid-sized company, even by a tech giants. Most of the time, Git is used. It has an overwhelming market share. This is what is all about the Git. There were a lot of players who tried to destroy Git. These were one of the players. Then comes the GitHub era. Social coding and collaboration. It's like Facebook of coding. In order to say GitHub era was like Facebook of the coding platform. The mid 2000s ushered in a new chapter for version control, transforming Git from a powerful command line tool into a social ecosystem that revolutionized how developers worldwide collaborate and build software. So 2008, the GitHub Genesis was founded by Tom Preston Werner, PJ Hyatt, and Scott Chachon. GitHub launched rapidly, turning the Git into an intuitive web-based social platform for code hosting and collaboration. GitHub pioneered critical features like pull requests, forking model, integrated issue tracking, enhanced open source discoverability, democratizing contributions, and accelerating project development. These were the things that the GitHub team has pioneered. Emergence of competitors. The competitors like GitLab, Bitbucket were the other alternative platforms and fostering a robust ecosystem. In 2018, they have acquired the GitHub for 7.5 billion, underscore the platform's profound impact and signal its mainstream institutional recognition. So GitHub was built as an open source project which was acquired by Microsoft for 7.5 billion. Clear? The whole point of GitHub was converting the powerful command line tool into a social ecosystem that revolutionized how developers collaborate and build softwares. So if you see the timeline era, local era, was IEB update, SCCS, RCCS. Centralized era was like CVS, Perforce, SVN. And distributed era was like Git, Mercurial, and Bazaar. So this distributed version control system where what happened was like no single point of failure. Every clone is a full backup of the entire project history. Offline work capability. That means we can commit, branch, merge the code without any network connectivity. Powerful branching. That means lightning fast branch creation and sophisticated merging strategies. The DVCS concept changed the game by storing complete repository history on every user's machine. That means what? Every user will have a complete history of the repository, unlike central version control system. So let's see the differences between centralized versus distribution version control system. In the terms of architecture, single central server hosts the entire repository. Developers check out files and commit changes back to the central server. So here in the DVCS, that is distributed version control system, every developer has a complete copy of the repository, including its full history on their machine. Workflow requires continuous connection to the central server for most operations. Here in the workflow, most operations can be performed locally without a network connection. If a central server goes down, no one can commit changes or access history or collaborate. Here, since multiple copies of the repository exist, ensuring redundancy and data safety. Offline capabilities. Developers can only work out on the checked out files and cannot commit or view history offline. If you don't understand what is checkout, commit and all, don't worry, we will discuss this command or concepts in detail. Developers can commit, branch, merge, and review history offline. Then they can push the changes later. Branching is a cumbersome process in SVN or centralized version control system due to server-side operations. It's a lightweight and cheap. It encourages frequent short-lived branches for feature development, experiments, and bug fixes. Collaboration model relies on direct interaction with the central server. Merging can be complex and conflict-prone. It allows for diverse workflows and facilitates peer-to-peer collaboration. Clear? What are the advantages? Easier initial setup and administration for smaller teams, centralized control over code-based access, robustness and data redundancy, faster local operations and offline work, flexible workflows and improved collaboration. What are the disadvantages? Single point of failure and data loss risk. Network dependency for most operations, more complex branching and merging, steeper learning curve for new users. Initial repository cloning can be slower for very large projects. And according to me, these are not major disadvantages. This is something like it is lot better than these disadvantages. Data loss, network dependency, more complex branching and merging. Compared to this is lot better. Okay, steeper learning curve for new users, I totally understand. If you sit for a week or 10 days, you'll be accustomed to the Git ecosystem. So you can see the timeline exactly in which year what has been used. Hmm? So the specialized solution, plastic SCM. This is mainly used in gaming companies. Helix Core is a large binary asset management. AWS Core Commit is cloud native Git repositories. What is the future of version control? Massive scale management, handling enormous repositories and binary SS efficiently, addressing the needs of game development, AI ML models, and multimedia projects. AI powered intelligence, integration with artificial intelligence for smarter merge conflict resolution, automated code review, and predictive analysis of development patterns. Beyond traditional code, expansion into managing infrastructure as code, design files, documentation, and configuration. Emerging tools seamlessly blending version control with project management issue tracking. This is the future of version control management systems. So, embrace version control to empower collaboration and innovation. So, from punch cards to distributed systems. So, 1962 was more like a punch card mechanism system. VCS have fundamentally revolutionized how software is developed and maintained and scaled globally. Mastering tools like Git isn't optional, it is essential for modern developers and teams competing in today's fast paced technology landscape. Version control transcends being merely a tool, it's a foundation of quality, effective teamwork. So, if you see the Git's overwhelming presence, almost 85% of the market share is Git only. Got it? So this is what is all about the version control system. I hope everybody is clear in this room. Yes or no, guys? Is everybody clear?
Yeah, Rahul.
So, yes. It's important to know the history of the version control system. Without knowing the history, it will be like a little nightmare for everybody. Cool. Shall we get started, everybody? So, before we start with Git, I need someone to help me share the screen for a Windows laptop to demonstrate the Git installation. Okay. Can anyone share the screen? Any Windows system to help demonstrate?
Yeah, I will share the screen. Is it visible, Rahul?
Coding. Yes. Okay. Let me take the control. For Apple and Linux users, Git is installed by default. Uh, have you given the control to me, Vinay?
No, Rahul. We need to give control.
You must be getting one pop-up that I'm requesting for control.
Okay, I
Mhm.
give it.
So, okay. So search for Git download. Git install for Windows. So if you see here, click here to download it.
Rahul is asking yellow. Can I click
Yeah,
yes?
yeah, yes, yes, you can. Have you clicked on yes?
Yeah, yeah.
Okay. So install. Okay, we are installing the latest version of Git in your system, Vinay. So you are using some older version, so it will be. Okay, since you have Git already, so click on finish, guys.
Okay.
So Git is already present in your system. So can anyone have a fresh system where Git is not installed? In your system, Git is installed, so can't help anything. Anyone has a fresh system where Git is not installed?
Mine it is installed already.
Yes, yes. In no fresh system, then I mean I have to have Windows laptop, which I don't have currently to showcase. Okay. So just now I've shown you how to download and how to do the setup. If you are using some older version of Git, please upgrade it to the latest version, guys. Okay, cool. So in my system, we have Git installed already. Git double hyphen version. Okay, I'm using Git 2.54. That's great. So generally, in order to run your Git commands, we use the basic terminal or a command prompt, or we can also use warp. Warp is a AI powered command line terminal tool. Okay. So warp is something, let's all use it together. Warp.dev. Okay. You can download this warp in your system and keep it ready. And if you check the pricing also for free, you can use it. Bring your own AI inference. For free also you can use it. Clear? So you can use this for free. It's a AI powered terminal platform, which I highly recommend everyone to use it. Cool. You can use your terminal or you can use your command prompt, but it's good to use something different. Got it? So here, since I am using a bit of Mac, so I'll be using a bit of Linux commands, guys. So if you don't understand anything, please let me know. So currently where I am, when I say PWD, it will let me know currently which workspace I'm in. So I'll say CD desktop. So I'll be going to the desktop folder. I hope everyone knows these commands, right? PWD, CD. If you don't know, please let me know, guys. I'll explain. So PWD stands for present working directory. That means what? Currently in which directory I am present. The Linux commands. CD stands for change directory. So what is the syntax? CD, whichever folder name or file path. Clear, everyone? Is this clear, everyone? All good?
Yeah, Rahul, clear.
If you have any doubt in the Linux commands, please let me know, guys, so that it'll be easy for me to clarify them. Cool. I will be sharing all these commands, guys. That's not a problem. Okay. Now, here in desktop, I will create one folder called as git concepts underscore weekend by mkdir stands for creating a new folder. What is the syntax? Nkdir folder name. So guys, it is minimum to minimum that we need to know all these commands, because going forward, whenever you are using cloud machine or any machine across the globe, these are the commonly used commands. Even in Windows also you can use these commands, guys. Creating a new folder based on the given name. Okay, so how do I go inside this folder? Cool. Cool. Now let's create some files. How do we create some files? I'll say touch first set of data.txt. When I say touch, it will create that particular file. Creates the file based on the given name. So if I want to write the data inside this file, I'll say cat greater than first set of data.txt, where I will be writing the data to the file. This is the first set of data that we are writing inside this file. Let us learn the Git concepts efficiently so that we all can understand the things very clearly. Git commands is one of the essential concepts for every industry. So I have finished this. Now, how do I save the changes here? I press Control C. All the changes will be saved. Cat greater than file underscore name writes the data to the file. Once the data to be entered is completed, press Ctrl plus C to exit from the file.
I hope you understand like how strong it is. This clear everyone? That OpenAI or your model now is so smart that it is telling that okay,
Clear?
after logic depends on the email class. It will never fail. I hope that makes sense to everyone. Like how we are having someone who is not aware about these things, he will just be able to define it immediately.
So what next?
Rahul, where you write in these comments?
The
See
comments are in a notepad file, right?
before slide one.
Here, I'm writing cat greater than first set of data.
This CMD or notepad?
This is CMD. I mean the warp terminal which I was telling you.
Okay.
System prompt is something which your model only is handling.
Okay. Now what next? Now if I want to view the information in the file, when I say cat, I can add the information of the file. Got it? View the information present in the file. Got it? Cool. Now we have seen this. Like this, let's create couple of files, guys. Second set of data.txt, third set of. So if I say ls-l, I can see the list of files that has been created. ls-l means we can see the list of files that has been created. Got it? Now, let me write the information. That is, let me write some information. This is the second file that we are creating for understanding the new set of operations. Going forward, we need to add more information or details to this file for better understanding. Clear? Now, imagine that we have created some new files. If I say ls-l also, you see here, it will say who has created the file, what is the size, what is the byte number of bytes present in the file, at what date it has been modified, last modified. Cool. Now what next? We have created files, we have done all these things. Now, is this a Git project? So, like, let me say git commit something. What it is saying, hey, if I'm running some git command on this, hey, it is saying like, hey, yours is not a git repository. Got it? It's not a git repository. So any project, whichever we want to link it up with Git, we need to first of all make it recognized as a Git project or a Git repository. How can we achieve it? How can we achieve it? I will say Git init. So this is what it has done. So it has been initialized a Git repository where it is using default branch as the master branch. Branch means what? That particular line of code. Got it? Clear, everyone? Any doubts? So in order to write this git commands, how can we write this git commands? So let's make a note of all the git commands here. Git workflow. Or else I post. So what I will do? First, imagine that I have a project where all the files are present. Then what I will do? I'll say git init. So what happens ideally? Initializes a Git repository for the folder that you have. Is this clear, guys? Any doubts? This is where git init is used. Without git init, for the first time, we cannot achieve it. So git init is like once per project or folder. Okay, this is like a one-time activity. You need not do it repeatedly. Correct? Now what next? The next thing is that, hey, I have to add the files. So first of all, what we will do before performing any git commands, I'll say git status. What does it git status tell you? The git status will tell like, hey, no commits yet, untracked files. What do you mean by untracked files? That means git has not started tracking the changes for these 3 files. Git status. What is git status? Displays information about in the initial stage. What it will display is about information about untracked files. So let me give the definition of untracked files. Untracked files are nothing but the files or changes that are not being tracked by Git. These are known as untracked files. For suppose, let's understand only untracked files because we are doing it for the first time. So it will display only untracked files in this case. Now what we need to do? Now we need to add these files to the Git ecosystem. How do we add the files? Git add first set of data.txt, git add second set of data.txt. Now since I have 3 files, I'm running the command for 3 times. So Rahul, you're doing it very one by one. Can we do all the files at a time? Yes, we can do all the files at a time. I will show you that. So the beautiful thing about warp is that it is saying like, hey, in which branch I'm currently using, what changes are there. It will easily tell me all these things. If you're using a normal terminal, it will be very difficult for it to say. Got it? Clear, everybody? So I have added all the 3 files. So for some of you, it might feel like, hey, we all know all this. Yes, we all know this. But the thing is that we need to be very clear with what commands you're using, because if you're not clear with what commands you're using, the conceptually, the internal layer, there'll be a problem for you. Because if some issue comes, you should know the internal architecture or internal nuance of it. Add the files to the Git tracking Git repository. So you might be like, Rahul, where is this Git repository initiate? Where is this Git repository? So when I say Git init, it initializes a Git repository. So in that Git repository, it adds the files. Got it? Whenever we are adding the files, we are not adding for the sake of adding it. We are adding these files to the Git repository so that it will keep a track of the changes. Okay? Any doubts, everyone? Amrita, Vinay, Radhika, all good? Cool.
Yeah, Rahul.
So we say git commit -m. What is the message? Pushing the changes for the initial set of files that we have. Cool.
It is again having still the type of content now. But this is again the backend, the file ID, file type.
Cool. Git commit -m means what? Pushing the changes for the initial set of files that we have. Cool. Commit means what? It's similar to like how we are submitting the answers to the answer sheet. That means what? You're confirming the changes for the files that you have added. Because Git is something like you added means that doesn't mean that you're confirming the changes. I need a proper approval or a proper confirmation from your side that you're okay with these changes. Got it? You see, it is creating one more, 3 file change, 3 insertions have happened. All these things. Got it? So what I will do here, git commit -m. So providing a message is mandatory because the Git will confirm your changes based on the message that you have passed. Because whenever someone takes a log of it, you based on the messages only you can understand at what time what you have done or something. So you need to provide a valid message. Whenever you are committing the changes, you need to provide a proper message. Confirms the changes for the files added to the repository. So confirms the changes for the files added to the repository with a proper message. Clear, everybody? Is this clear, everyone? Giving a proper message is mandatory, guys. Now, when I say git status now, we are on the it will say which branch we are in currently. Nothing to commit, working tree is clean. Got it? Now, all the changes are present in your file. All the changes are present in your system. That is fine. Now, if I want to take it to GitHub, that is a social coding by social platform. Like how we have Facebook as one of the social platforms. For GitHub is like the social media platform for developers and coders to collaborate their changes, collaborate their workflow. So that is where you guys need to create an account on GitHub. I hope how many of you guys have created an account on GitHub? If not, please create it. Clear, everyone? Is this clear, guys? All good? So what I will do here, let me create one repository. Cool. I'll say understanding Git concepts. Cool. Choose visibility. As of now, I'll put it public because we are just here to learn the Git commands. Cool. Now this is how we create a repository, guys. I hope everyone is clear, right? How we have created a repository. Everyone in the room? Amrita, Kiran, Manish, Radhika, Vinay, all good?
Yes.
Now, once we create a repository, so in today's class, I will show you how do we set up a repo, how do we do it using HTTPS. In the subsequent classes, I'll show you via SSH. So what I will do here, let me copy this repository link. I will say git remote add repo URL. So what is this, Rahul? Add repo URL. So that means what? You are changing whatever tracking you're doing it in your local system. Now, what is this add repo URL? That means what? Now, tomorrow, if you want to push the changes to the GitHub, to which GitHub repository you want to push the changes is the question. Got it? To which GitHub repository you want to push the changes? That is where we are writing the code. Got it? So what I will do now? Enter. Git remote add whatever variable name you want. Clear? Is this clear? Any doubts? So what does it do? Adds the repository URL to the given variable name so as to push the changes to the push means what? Whenever you want to move the changes from local to local to some cloud repository or third party repository or some external repository which is not part of your system, that is called as push. So the word push is nothing but moving the changes or files from local system to the remote system. For your easy understanding, I'm saying remote system. In real term, in the real world, we say it as remote repository. Got it? So there are some words where some of the people might be new. I'm just writing everything for them. What do you mean by commit? Confirming the changes for the files that has been added to the Git repository. Got it? Now, once I did this git remote add URL, I will say git push -u repo URL master. Why master? Because if you see here, we are using master as the name for the initial branch. Whenever you have created a GitHub repository, by default, it will create master as the default branch. Branch is nothing but a separate line of code base that is used. Okay. Cool. Any doubts? Now the changes has been pushed. Clear, everybody? Any doubts so far? All good? Guys, I want everybody to confirm. Can everybody confirm in the chat box, guys? Is everybody clear or not? Branch name or master if you are using the default branch. Yes, Ahmad? Yes, Ahmad, do you have anything to ask? pushing the changes to the remote repository. Cool. This is what is all about the basic Git commands. This should be something that should be clear for everybody. And this command is used once per project. It is not like every day we use it. Clear? This is a regular workflow that we use it day in and day out. Cool. Anywhere in this workflow, anyone has any doubts? I want to get these things clear before we go ahead with the next concept. Hmm?
Yeah, what about the git revert and git rollback commands?
Will come. First, you understand this.
Okay.
If the normal workflow is not clear, then if we put some more complications, then it will not be clear for you, right? This is something that is very, very, very basic, which you all need to know. One more thing with Git, please be a little patient when you're doing some operations. Don't execute the commands just out of the blue. Be little patient. Think once or twice before writing any Git command. I can tell you from my experience that a lot of people have performed the Git commands in a haste and they have lost their files because they have not understood how the tracking is happening. So don't do those mistakes right from the beginning stage. Git is not optional, guys. Git is mandatory because I have seen lot of non-IT friends using Git to a crazy extent. So we as IT professionals, we should not take a step back in terms of Git. Cool. So this is a working mechanism. Now, the above workflow is something that we use that we use only when we are creating a repository for the first time. Now, what is a daily workflow? Daily workflow. How we do it daily? So I'll say cat greater than third set of data. This is the third file that we are writing the information about the Git concepts. Let us all be clear with the changes that has been progressed so far for a better understanding. Something we have written. Then I'll say Control C to save the changes. Got it? So what is the daily workflow? First and foremost command, we say git status. What happens when we say git status? So this is the current project folder. Every day we have to say git status. So it will say changes not staged for commit. What do you mean by this changes not staged for commit, guys? Can anyone guess what is the meaning of this changes not staged for commit? Guys, any guess what is the meaning of this? Hmm? Guys there?
Git is not tracking the changes for the next commit.
Mm-hmm. What else? So what are the things that git status displays? Displays information about untracked files, changes not staged for commit. So what is this not staged for commit? This is something that needs a very clear understanding. Changes not staged for commit means whatever that means files are already tracked. The latest changes made for that particular file are not tracked. I hope this is clear, everybody. Changes not staged for commitments, what? Already the file has been tracked, added to the GitHub repository, but whatever new changes that you have added, those are not tracked. Got it? So what I will do now, git add file name. Adds the files to the Git repository. So I'll say git add third set of data. Now I'll say git status. Then it will say changes to be committed. So for some people it might look little redundant because we already know this. I agree, but there are certain people who might not know it. And if you already know also, you might not know the science behind it. It's always good to know more about Git because this is something we use day in and day out. Git status, what does it? Displays information about changes to be committed. What do you mean by changes to be committed? That means you have added the files. Now, what are the changes you have to commit? It will just display those information. Is this clear, guys? All good? Now, once you commit for the third file that we have. Cool. This is our daily workflow, guys. Whenever you start your day or whenever you're trying to push the changes or whenever you want to do, this is one workflow that we need. This is like a golden workflow that we need to follow. Commits the changes to the Git repository. Cool. Then followed by now when I say Git status. So in the real time, we have to use Git status after every activity. On branch master, it will say like your branch is ahead of repo URL by one commit. So always remember that whenever you're checking Git status, your message should be like your branch is ahead of remote repository by X commits. Your branch should not be behind the branch present in the GitHub. Your branch should be always present ahead of the branch present in the GitHub repository. That means what? Whatever changes you have made, I mean, always the word ahead should be there. If it is saying behind, that means you have lost data. That means the concepts of Git that you need to follow, you have not followed the commands properly. You have not managed your code properly. You should always see this message that your branch is ahead of repo URL slash master. When I say repo URL slash master, means repo URL represents the remote GitHub URL. In that, I'm referring to the master branch. Got it? Clear, everybody? Displays a message that your changes are ahead of remote branch by X commits. X can be any number. I don't want to commit it. Cool. Now what I will do next? Then I'll say git push -u. -u stands for upstream. Upstream means what? I have given you the definition of push, right? The same thing. Git push -u upstream the changes. Upstream means local to remote. Variable name, whatever variable name you have declared, and branch name. You can decide which branch name you want. Sorry. Git push -u repo URL master. Clear? I hope this is clear, everybody. Pushes the changes to the remote repository. So some of you might be asking, Rahul, this is something we already know or some YouTube can give. Why are we discussing all these things? The reason behind it is in YouTube or any Udemy, you will see the commands. They'll just give you the commands and this is the flow you need to use. But what is the meaning behind these commands? What is this -u? What is this variable name? What is the status? What is the meaning of this message? This is something we need to be very clear of it. Without reading these messages, and if you're trying to perform the Git actions, then you will be the culprit for loss of code. Read the messages, understand what is happening internally. This is something that we are focusing on. Because without Git, I don't trust you guys have done something. No matter you develop some kick-ass application, if you don't know Git, you're not fit to publish your application anywhere. Clear?
Create a GPU. You see that how it is asking for instructions, how it is
Cool.
asking for them to understand that how it is asking. And we look like a system. Whenever you are defining, so what I have done is give it a name.
I hope this is clear, everyone. Good to go.
For it, I have uploaded lots of things. Give it some consideration pattern and recommended model. I have just pressed a user to any of them. Given it all these capabilities.
So I hope everyone is clear with the daily workflow. What happens when you do create a GitHub repository, how we need to do the daily workflow, all those things. Daily workflow is something you need to remember, guys. What happens behind the scenes? You need to follow these exact steps and understand each and every message. If you don't understand each and every message, that would be a problem. Be little patient with Git. This is where a lot of dev teams make a lot of errors, or even QA with respect to automation scripts. Certain test cases needs to be executed, so fixes has been made, but it is not working. Got it?
welcome message, example form. But for us,
Cool. Any doubts so far? All good?
always like
I expect everyone to be clear, guys. Silence doesn't mean anything. Please.
Yeah, Rahul, go ahead.
it requires
Okay. So just take a quick 10-minute break and we'll start with the branching concepts.
speed. Okay. This is a very good official example.
Go for a quick 10-minute break, guys. We'll be back.
And picture, but yes, it is
Cool.
great. Any doubt till now?
Yes, I hope everyone is back.
AI message. For the very first yes, for subsequent calls, AI message also becomes there. Right? Like we are also sending AI messages. But yes, AI message is what AI is generating.
Yeah, everyone is back in the room.
Here. Metadata of the filter messages.
So, what next? So, let's understand the concept of branching and merging. That is the most important concept that we all need to know. So, what do you mean by branching? What do you mean by branching, guys? Can anyone tell me what is branching? What is branching, guys? You might have heard the word branching a number of times and you have been hearing or listening to it. What do you mean by that? Yep, what is the meaning of branching?
What we done the work in the storage that branch.
Mm-hmm. Others? Amrita, Kiran, Radhika, Vinay. Yeah.
The developers or testers, they will have to create their own branches to work on that, right? So, like creation of different branches, basically.
So let's take some Google definition about what is branch. Movable pointer to a specific. So it represents an independent line of development, acting like a separate workspace or a parallel universe where you can. Got it? First, let us put what is a branch. What is branching? What is a branch? It represents an independent line of development, acting like a separate workspace or a parallel universe where you can write the code, fix bugs, experiment without affecting the stable main code base. Got it? Acting like a separate workspace or a parallel universe where you can write code, fix bugs, or experiment without affecting the stable main code base. So why use branches? So why we use branches? This is the purpose of it. Isolate work. That means what? Develop new features without breaking the live code. Parallel teamwork. That means multiple developers can work on separate tasks simultaneously. Safe experiment. Try risky code changes and simply delete the branch if they fail. These are the perks of branching. What happens in under the Git when I create a branch, when we push the changes for a particular branch, how the Git works, we will see them practically. So I hope everyone understood what is a branch, why branching. Branch represents an independent line of development which is acting like a separate workspace or a parallel universe where you can write code, fix bugs, or experiment without affecting the stable mode code base. That is the whole point. Now we have 8 resources in the room. We are working on the same project. We can create 8 different branches. That means 8 different lines of code, 8 different developers working together on the same project where we are working in isolated workspaces. Your work is not impacting mine, my work is not impacting yours. Suppose I ask one person to experiment the changes and see how it is working fine. So you can create an experimental branch and you can try pushing the risky code changes and simply delete the branch if they fail. Got it? So that's the thing. That is what is all about the branching. This is the branching. So what is the syntax? Creating a new branch. Can anyone guess what is the syntax of creating a new branch? Some people who might have worked already, like Kiran, Vinay. What is the syntax of creating a new branch?
Git branch name.
Hmm?
Git branch name.
Okay. Git branch name. Okay. Anyone else? Anyone else? Do we have any other syntax of creating a branch? So there is one more command called as git checkout -b branch underscore name. Okay. With switch -c branch underscore name. What is this git branch name? Creates a separate branch based on the code present in the master branch. So what does branching mean? It is not simply like creating a branch. So if you see here, currently which branch I'm in? Master. So if I say git branch, if I say git branch, dev branch. So what does it do? Got it? It is saying what? Git branch, dev branch means what? I have created a branch. If you want to see currently which branch I am, you can see currently I'm in master branch. What does dev branch contain? Dev branch contains the code that is already present in the master branch. Got it, everybody? It is not like never always remember branching never create. You will never ever create an empty branch. Clear? You will never ever create an empty branch by default. So currently you're in master branch. If I say git branch dev branch, that means it will create a copy of the master branch code present in the master branch into the dev branch. That is the actual behavior. Got it? Now, what is this checkout -b, Rahul? What is the difference? Creates a separate branch based on the code present in the master branch and creates a separate branch based on the code present in the master branch and it switches to that particular branch. So what is the thing that is happening here? We are creating a branch, but still Git is telling that, hey, you're still currently in master branch. How do I know currently it is in master branch? You see the star symbol here, star master. That means what? Still we are in the master branch. Got it? Clear, everyone? Now, if I want to switch to this branch, like for suppose if I want to switch to a branch, switch to a particular branch, git switch that particular branch name, git checkout particular branch name. These are the two commands that we can use. Useful in the latest versions of in the Git versions above 2.40 if we are using older versions of Git. Clear, everybody? Any doubts? Here git switch -c also the same command it does. Is this clear, guys? All good? This is how we create a branch. If anyone in an interview asks you, you need to be clear about different syntaxes. They don't expect you to give a one single syntax. They expect you to give the explanation what is happening. It creates a separate branch, but it will not switch to that branch. That's the difference. Got it? How do I switch branches? I'll say git switch dev branch. So if I say git branch, you will see that currently which branch my code is present. Got it? So always remember that git branch will display the list of branches present in the local along with show along with it display along with it displays which branch that we are currently upon or using it. Clear? Along with it, it displays the which branch we are currently upon or using it. This is something we all need to know. Is this clear, guys? What is branching? Why branching? What is the syntax of creating a new branch? Cool. All good, guys? Good to go? Cool. Now, let's create more branches, guys. Git branch, QA branch, Git branch. Wait. So it is triggering the warp agent to finish the task. Git branch, UAT branch. So there is one more beautiful thing in AND branch. Like there's one more beautiful thing called as double AND, which I'll be explaining it to you. This is something we all as SDETs or developers use this. So currently how many branches we have, guys? 4 branches. Got it? Yes or no? So let me explain the concept of branching very clearly. This is one of the site that we use it officially to understand the concept of branching. Cool. So what I will do here. So let me say currently we are in main branch. So let me show you the diagrammatical picture of it before me showing the real-time picture of it. Because if I show the real time, you will be literally confused. Got it? Cool. I will say git commit commit commit. So that means what we are doing, pushing some commits to the main branch currently. Cool. Now from here, what I will do, I'll say git branch, dev branch, git branch, UA branch, git branch, UAT branch, git branch, prod branch, something like this. So now how many branches are there? Now total say five branches are there. Now what I will do, let me switch to dev branch. Switch command is used to switch to the dev branch. Let me make some commits here. I hope this is clear for everybody. So I'm making some commits here for the dev branch. Now let me switch to QA branch. In this also I will add some files, or I'll add some configuration files or something like that. Is this clear how the branching is happening? We use these kind of tools at an architect level to really decide how the branching should happen. Before we communicate the message to the team, we as SDET engineers or a senior QA persons, everyone will sit like this. We draw the branching diagram like this, and we decide how the branching strategy should happen if you are working with heavy team members. Because if you don't define the strategy, it will be a mess. It'll be a mess. Everyone will do their job. They will follow their own rules. Git is one of the free flowing tools. That is where you need to set up some rules or ground rules. So let me switch to UAT branch. Git branch, git commit. I hope this is clear, everyone. Commit. So this is something that we see in real time. Clear, everybody, how the branching is happening? The visual diagram is clear for everybody. Any doubts so far? Clear, everyone? Cool. Cool. Now what next? Now it's time to merge the changes. How do we merge the changes from dev branch to QA branch, or QA branch to UAT branch, or something like that? How do we merge the changes? So I'll say git switch. So where you want to merge the changes? Now you need to establish a rule. Now, currently where you want to move the changes from dev branch, I want to move the changes to the QA branch, correct? So if you want to move the changes to the QA branch, first you need to be in QA branch first. Then I'll say git merge with dev branch. Whatever changes that you have made in dev branch, that will come and sit on top of QA branch. That will sit in, that will, the whatever commits you made in the dev branch, those commits will come and sit on top of C24, on top of the commits made in the QA branch. Got it? Now what next? Now after merging the changes, you realize like, hey, I have a lot of commits. I have to do a couple of commits because when we merge, some errors came. Okay, let's fix those errors. Now, once those errors are fixed, then I want to merge the changes to the UAT branch. How will you merge it? So currently you're in which branch? QA branch. So I will say git switch UAT branch. Then, since I'm in UAT branch, I will merge the changes with the QA branch. So whenever you're merging the changes, you should know currently in which branch you're in. From you want to move the code from which branch to which branch, you need to have that utmost clarity, else it will be a mess. Got it? Cool. Now, at the end of the ultimately, I will do some commits on top of it. So just to some configurational changes we can say. Now what I will do, whatever changes I made it here, git switch prod rank commit. Is this clear, guys? Any doubts? So this is what is all about the branching and merging. No, wait. So merge UAT branch. Clear, everybody? How we are merging the changes? See this hierarchy from dev to QA, QA to UAT, UAT to prod. This is the cycle that we follow across every organization. The moment we give a sign off on QA branch, we test it in UAT branch. The moment we UAT is signed off, then they move it to prod branch. So this is how developers do it. They move the changes, they merge the changes across, and they will do it. Cool. If you can understand this diagram, then it will be very easy for you in the real time. Cool. Clear, guys? All good?
Yeah, all good.
So this is how we do the branching and merging. Now, you might have a lot of combinations in your head, like Rahul, this branching, that branching, the team members. Now you've shown between dev, QA, UAT, and all those things. That we are clear, that we are perfect. Now, imagine that we want to do automation branch merging between team members. There'll be one person who will do the framework designing and all those things. So what I will do here, in the main branch, let me do some commits. So now a new person will called as git branch architect. Some architect will come. I'll say, let me commit those changes in the architect as an architect. Let me commit those changes. He will design the framework and he will make those changes. Now what happens now? The architect, whatever changes he has done, he will try to merge it with the main branch. So what I will do, I will git switch main architect. Whatever changes the architect has made in this branch, I will merge it. Got it? Now from here on, I will say git branch, git branch. I'll say, now imagine that I have three resources. Now I'll say, now Kiran has, now I've created three branches for three resources of my team. Okay. Now once I create three branches for three resources of my team, what will happen? Now let me switch to Kiran branch and let me do some commits there. This is a very real-time scenario when you're working as in automation testing with different teams. Cool. Cool. Then I will say git switch Vinay. So they will also be doing some commits. They will also be doing some commits. Git switch Vinay. Cool. So all you guys have committed the code. Now architect felt like, hey, I need to make more changes in the code base. Git commit, git commit, git commit, git commit. He has done a lot of changes. Correct? Now what next?
Let's take it multi-model SQL agent. So when you complete it by launching RAM,
Cool. What next? So I'll say git commit. Now what next I will do? I will say like, hey, this is an architect. Now whatever changes architect has made, the latest framework changes have to take it for all the branches, right? All the branches to take the latest code changes, right? So what I will do, git switch given, git merge architect. Whatever changes the architect has made, I would like to take it. Now I'll say git switch Radhika. Okay, git merge. Whatever changes architect has made, I have to merge the changes. Got it? Git switch Vinay. Whatever changes architect has made, you have to make it. So now you see the workflow here. Whatever, whenever architect made any changes, it is our responsibility to take the changes into our branches. Got it? Now, Vinay felt like, okay, there were some errors. He has changed some arguments and he has made some changes. Commit. Cool. Kiran also feels like he has to make some changes. Cool. Now tomorrow what happened? Now tomorrow Radhika went on leave for some vacation. Now who will do her work? Now Radhika's account, Radhika branch is in her thing. She has pushed the changes. So if you directly work in Radhika branch, Radhika will not understand what has to be done. So what happened was like, okay, two junior resources were they are present to replace Radhika work for 1 week, 10 days. So what I will do, I'll switch to Radhika. Imagine that she went on leave. Now someone has to take the responsibility of it. So two resources are tagged to it. I will say switch -c R1, that is resource 1, git switch -c R2. Radhika, git switch -c R2. Now you see here, I have two resources under this. So what they had created another sub branches from Radhika. So what I will do now, I will say git commit. So they have been working for two modules. They will be committing the changes. Switch R1. Even R1 is also working on changes. This is how complex the branching could be, guys. If you want, we can make it more complex. Clear? git commit. Now, what is the next thing? Now, R1, R2 are the resources that they have worked on. Now, Radhika is back from vacation. Now, once she is back from vacation, what next? Now she has to look into the code and she has to merge the changes, right? So she will be like, hey, R1, I've come back from vacation. Could you take the responsibility of whatever code changes you have made, validate and let me know so that I will merge with your changes? Then R1 takes the responsibility, switch R1. Then they will merge the changes with R2. Then what I will do, R1, if he feels like some errors are there, they will fix the errors together. Then what happens? I will say git switch Radhika, git merge with R1. So if you see here, internally, there's a lot of merging happening. This is what happens behind the scenes, guys. You need to be very, very, very clear of what is happening here. Clear? Now Radhika is back from a vacation. She has looked into the code changes and she has merged the changes happily. Now, the manager asks like, hey, I want everybody's changes to be merged back to the main branch. So, Vinay, you take the or Kiran, you take the ownership and merge the changes. So what does Kiran do? First, Kiran will be like, hey, first I will merge Vinay's changes as I said it's completed. So whatever changes Vinay made, that will come into the Kiran branch and he observes some errors or something like that. Cool. Then later, he asked Radhika to, can I merge your changes? Yes, he can merge the changes. Merge, Radhika. All Radhika's changes are present here. Cool. Now, once all the changes are validated, the manager sees the code in the Kiran's branch, and if once everything is working fine, I will say like, hey, let me switch to main branch, merge Kiran. Whatever changes Kiran has made, it will be merged. Clear, everybody? This is what happens. This is like one of the simple workflows of Git branching that we can see, guys. Cool. Of course, this is little simpler compared to the ones that we work in the organization, but these are these are some popular workflows that we discuss, deal with in our team. Now, Vinay says like I have to start working on a new module. He'll say git commit and he will work on the changes. So everyone can still keep on working on the changes. Clear? So this is something that we all need to understand or realize. So till here, please practice it. Please make a note of it because going forward, when I show it practically, it will be little heavy, guys. The branching concepts. So we will take up this concept in the next weekend, the branching, strategizing more in detail with GitHub. So please understand, please go to the site, try to apply your different branching combinations across different combinations, and we will see what is happening. Clear? So next class onwards, it'll be like a proper session. First off, we'll finish the branching and merging concepts. And the next class, in the next class, we will also try to cover rollback, reverts and all so that you'll understand all the concepts. Cool. So next class will start with branching and merging practically. This is all theoretically, diagrammatically, I'm showing you all the things. Cool. So far, any doubts, guys?
No, no, everything clear. Can you share me the document, Rahul? Morning you explained this. Version
Which
control. Version control document.
that one, okay. We'll share, like I'll share to admin team, they will share it with you.
Sure.
Okay. Cool. So please practice, guys.
Rahul, I
Yes, yes.
already joined the previous batch, right?
Yes, yes,
So
I
right
remember.
now, I'm in weekend batch. Is that admin team will give the separate element?
You can coordinate with the admin team on this. They will help you out.
Okay.
Okay, guys, we'll see you in the next weekend.
Thank you, Rahul. Bye.
Thank you.
Mm.